Welcome to our new unit. This is going to be our last unit of the year. New material. We are going to do a little review as we head into through the rest of May and into June. But let's take a look at 10.1. So our objective here is talking about piecewise functions. Piecewise functions are essentially going to be two or more graphs that are actually connected together over certain x values. So you might graph a certain graph from 1 to 5, and then you're going to switch to a new graph after you get to 5. That's kind of what a piecewise function is. So on the first one, we want to talk about creating our graphs. And so the first graph here for part A is going to be the absolute value of x, which looks like this. So you can see the points are located at 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. Okay, so what we're going to do for our purposes is just graph that real quick. So we know if we go 1, 1, we can put a dot, 2, 2, 3, 3, and then negative 1, 1, negative 2, 2, negative 3, 3. Okay, so going on up here, we have this graph. All right. Okay. So remember, we need arrowheads, and then we're going to have our label, y equals the absolute value of x. All right, so the next graph is going to be y equals absolute value of x minus 5. And we can see that essentially all that happens is we're shifting the x values 5 units to the right. Okay, so the reason we're doing that is because even though it's minus 5 in here, right, in order to go from a point, let's say this point, right, which is located at 0, 5, I actually have to move left 5 units. So I have to put a positive 5 in here to get this. So that's why the positive 5 is what I would plug in to get this graph. So that's why we're shifting 5 units to the right, because I have to plug a positive 5 in to make that happen. So if this was x plus 5, I'd have to make it minus 5 to the left in order to make them even. Kind of a weird explanation for it, very general one, but that's essentially what's happening here. So now in our second graph, right, we're starting here, and then our slope is still going to be, right, 1, 1, 2, 2, 3, 3, going on up. So we're still going to have that same slope. Sorry, not 1, 1, 2, 2. It's going to be, sorry, misspoke there. It's going to be over 1, up 1, over 1, up 1, over 1, up 1, right, over 1, up 1. And so we're going to get these two graphs right here. All right. So there's our two equations. Once again, got to make sure we're throwing arrowheads on there, or that we've extended the line off the graph or to the end of the graph. And we don't need the equations, but we're going to put them in there. If we have two of the same, we do. So write a brief summary comparing and contrasting the two solution sets, right? And we would say the solution sets essentially are the points. So the graph of y equals the absolute value of x minus 5 is the graph of y equals the absolute value of x, just shifted 5 units to the right. Okay. So this is a sort of an example of what a piecewise function is. Okay. So we're going to look just at this part of the line, the function y equals absolute value of x minus 5. Okay. And we're going to actually talk about how to create this graph with lines. Okay. So the first line we need is anything less than 5. So where 5 is, if I want to go on this side, I essentially am going to draw that line. Okay. And for anything greater than or equal to 5, I'm going to go ahead and draw this line, okay? And so we can see that these two lines are actually linear equations, right? This first one, okay, we can see has a, and I'm going to do this one in blue, all right, has a slope of going right one, up one of 1, and the y-intercept, right, is located down here at -5. So this equation of this right side for any value of x greater than or equal to 5 is y equals, okay, x minus 5, 1x minus 5. And the other graph that's located over here, the red one, is going left one, up one to get my slope. So the slope is -1, and the y-intercept is located up here at 5. And so any value of x that's less than 5, right, not equal to 5, but less than 5, is going to follow the line y equals -1x or -x minus 5. And so these are the pieces of our function that create, okay, they create this graph, okay, that graph. Let's use some lines here. These two functions with these restricted domains, meaning that I'm only talking about the values, okay, on the left side of the graph that work in this equation, -x minus 5. Once I get to 5, and anything greater than 5, I'm then going to switch to this line. And so what that does is it takes this equation and it gets rid of this part down here, okay? Because we're only going to anything less than 5. And then when that happens, okay, I'm going to shift here, and instead, right, I'm going to, and as soon as I get to 5, I'm going to follow the blue graph up now, right? And when we do that, we use our two separate equations now to make this line, get to 5, switch to the blue line, and this is how the absolute value of x minus 5 is created, with these two separate graphs, okay, these two pieces. So G1 has a slope of -1 because it's going left one, right, up one, okay, and the y-intercept is +5, so it's -x plus 5. Oh, see, we messed that one up here. -x plus 5, okay. I wrote it over here. We just didn't write it in the equation. And the second graph, G2, which is the right side, has a slope of 1 because it goes right one up one. Okay, the y-intercept is -5 because if we continue the line, we're going to make contact down at -5. Okay, and therefore that where G2 has this equation. So this is how we write our piecewise function. Okay, we're going to say g of x, all right, which is the whole graph. Okay, and then we're going to put this brace down. So it's defining different functions for depending on what the domain is. And the first thing I'm going to do is I'm going to write my equations, okay? Then I'm going to put a space, and then I'm going to put my domain, okay? So normally you'll see I'm just going to write equation 1, and then domain, and then equation 2, okay? And then you're going to put the domain for that. And you can do more. You can do 2, 3, 4, depending on how many you need, okay, to make your function. So now, when you graph on an interval, for example, -4 is less than equal to x less than equal to 2, okay, that means you're only going to graph the values of x for that specific, for those specific x values, anything in that range from -4 to 2, okay? We're not going to use arrowheads, and we're not going to extend past those x values. So look at graph A, okay? I know the slope of this line is 1/2, so rise over run. Rise is 1, run is 2, so up 1 over 2, okay, or down 1, left 2, and the y-intercept is +2. So I'm going to graph this for anything from -6 to 6, okay? So let's go over to the graph, all right? So we know we're going here, that's my y-intercept, okay? and we're going to go -6 to 6. So if we want to, what I would advise you to do is to go and take your calculator, new document, go to the graph and type that equation in. So 1/2 x plus 2, and then we can get our table and we can graph those points, -6 to 6. So -6 is -1, 0 is -4 is 0, okay? I can also just graph from here on up. So I know it's at 2, and then I'm going to go up 1 over 2, right, to get to the next point here. Okay, up 1 over 2, up 1 over 2. Now that's 2, 4, here's 6, and then down 1 left 2, down 1 left 2, and then down 1 left 2. So there's my line. That's the first line. And I'm not going to put arrowheads. I'm just going to stop at the endpoints at -6 and 6. The second function we're going to graph is 5 minus x. So we'll do this one in blue. So the slope, and remember what we would normally do is write this differently. So we'd write y equals -x plus 5. So the slope, right, is -1. The y-intercept is 5. And we're going to graph from -1 to 5. Okay, so I'm going to go ahead and graph the y-intercept first. So that's at 5. That's 3, 4, 5. So that's right here. And then I'm going down 1, right 1. Down 1, right 1. Okay, down 1, right 1. That's 3, 4, 5. And then up 1, right 1. Or so up 1, left 1. And then I'm stopping. So here's 5 on the x-axis. Here's 1 on -1 on the x-axis. Those are my values. So I'm just going to go ahead and connect those with this line. And there's my 2 graphs. Okay, so the intersection point occurs right here. And that point has the coordinates 2, 3, 2, 3. Okay, and that is essentially what we're going to do. So if we wanted to make a function that only used the blue line here and then the red line up here, we could do that. We could say, look at, for anything less than 2, use the blue line, right? Once you get to 2 and more, use the red line. And then we would come up with that specific graph, that piecewise function graph. Okay, so let's do it. So this Heaviside function is defined as, right, we're going to use h of x equals 1. So essentially this means that for the first function, okay, what this actually means is we're going to use y equals -1 for any x value less than 0. So anything less than 0. When x is equal to 0, we're going to use the graph y equals 0. Okay, and for anything greater than 0, we're going to use y equals 1. All right, remember y equals our horizontal lines. So anything, okay, less than 0, so that's anything negative, uses the graph y equals -1. So it's going to be a line going this direction. Okay, and it's going to continue on forever. So we're going to put that arrowhead, and we're going to do it in blue because we want to be consistent. Now, what we need to do is put an open circle at that point, because remember, when x is 0, it's the y value, or the x value, is actually 0. So I'm going to put a point, okay, a point at 0. When x is 0, y is 0, okay? So we're going to go ahead and put a point right there. And then the same thing happens now. As x moves above 0, we're going to use the graph y equals 1. So we're going to get this graph right here. Okay? Change that back. And once again, open circle because we're not using that point on the graph. All right, that's it. And the last one, this is more of the one that you would normally see on the exam. Okay, so once again, what this actually means is we're going to use the graph y equals, or f of x equals, right? F of x. Okay, so the first function is y equals 2x plus 3. And we're going to do that if x is greater than or less than -1. As soon as x becomes -1 or goes bigger than that, okay, we're going to switch to the graph negative x plus 3. So this is how we read this, okay? So do this until you get to negative 1, and then switch to this, all right? So the first graph, right, that slope is 2 over 1, and the y-intercept is 3, okay? And for the second graph, all right, the slope is negative 1 over 1, and the y-intercept is 3. All right, so now we'll also talk about and how to graph this on your calculator as well. Okay, so what I'm going to do is I'm going to type this function essentially in my calculator. Okay, or at least figure out what the value is at negative 1. Okay, so if I take my function, and the easy thing to do here, right, is 2x plus 3, and if I plug 1 in, or negative 1 in, what do I get? Okay, so 2 times negative 1 plus 3, right, is negative 2 plus 3, and so this is equal to 1. So at negative 1, my first point that I would want to use, okay, is going to be the point at negative 1, the y value is 1. So this function right here, 2x plus 3, and what I would do, once again, if I were teaching you guys like I am now, but we were in school doing this, okay, we'd all have our calculator, we'd take the graph, and we would type 2x plus 3 into the graph, right in the calculator. We'd go to the table, and we would get the y value at negative 1, and we'd see, okay, at negative 1, that point is 1. So we're going to go ahead and put an open circle, because this is not an equal sign, okay, at negative 1, 1. So negative 1, 1, we're going to put an open circle. And now what we're going to do is we're going to graph the rest of the function. So the slope of that line is 2 over 1. So the next point on that line, we'll do it in red here, okay, is to go up 2 and over 1. And of course, I'm moving in a negative direction. So down 2 and left 1. Okay, down 2, left 1. And I'm going to continue moving that direction forever. Okay, so there's my graph. All right, there's that function, okay, until I get to negative 1. Once I get to negative 1, I'm going to switch now to this function, okay? So I'm going to go to my table. I'm not going to go to my table. I'm going to go to my graph. I'm going to hit Tab, and I'm going to enter in the second function, which is negative x plus 3, okay? Here's the second function. So now I'm going to go to my table. I'm going to go to negative 1. And I'm going to see at negative 1, this graph has a y value of 4. So the next function, okay, we'll do this one in blue, starts at 4. So I'm going to do a closed circle, 1, 2, 3, 4 at 4, closed circle at 4, okay. And now I'm going to use my slope, which is negative 1 over 1. So down 1, right 1, and I'm going to get this graph right here. And this is how I build this function. Okay, so I'm going to draw the rest of this graph in, and there we go. Okay, and normally when I'm graphing this, all of this is going to be in the same color. This is all going to be blue or red. Okay, so when we do our graph, we don't need two different graphs here. We're going to end up doing the same colors. Okay, but this is what the graph is going to look like when we're done. So when it's less than negative 1, I'm following this line until I get to negative 1. Then I make the jump up here and I keep going. Now on your calculator, okay, so we're going to open up just another calculator page. What we're going to do is we're going to press this function button, and you can see on this, just double checking here. Yeah, we're going to go ahead and hit the function button, and we're going to go ahead and choose our this guy right here. Okay, so there's a really good, so this is the MathBits website, and this is a great example of choosing how to do this. So What we're going to do for example 1, we have our example, so we're not going to use this one, but we can see the interval. So we're going to go over here. We're going to choose, right, this from the symbols button. We're going to choose this for our piecewise function, okay? And then what we're going to do is we're going to go ahead and enter in our two equations. We're in the spaces, and then the interval, the range or the domain for that one, and then we're going to go ahead and hit enter, okay? So that's all we're going to do. So press the button, choose it, enter in information into the two spots, and then go ahead and hit and graph, okay? So once again, we're going to open up our graphing page, okay? We're going to press the symbols button, we're going to choose our pick, and we're going to enter in our two equations. So the first equation is 2x plus 3, and then we're going to press the right arrow to switch over into the box where we're going to put our domain, and that's x is less than -1. Okay, then we're going to go down to the next spot. We're going to do 3 minus x, or -x plus 3, and then we're going to do x. Okay, now I have to go ahead and hit Control equals, so I can choose greater than or equal to, correct? Yep, and then -1. So now when I hit enter, the graph is going to pop up. Okay, now notice that there isn't any closed and open circles here. So you have to know that when this line, right, reaches -1, there's an open circle for this graph, okay, open here, and then it jumps up here. You have to be able to see that. If you hit T for table, it'll actually walk you through it. The thing you don't get on here is which of these is an open circle and which of these is closed. Okay, you cannot see that. You have to use this value, okay, to identify that. So that's what we did. We typed in the first equation, then we looked at what the values are here. We knew it's an open circle. We looked at the second equation in our calculator. Okay, we graphed that point as a closed circle. Use the slope to graph the rest of the way down. That's it, guys. That is Piecewise Functions Introduction. Have a great Monday, and I'll talk to you guys again tomorrow.